All right, we're going to talk about the worksheet that we kind of worked on in class the other day over domain, zeros, and the difference quotient. So I want to kind of do a quick recap of all this so you guys have no problem finishing off those problems and whatnot. So let's start with domain. We talked a little bit about domain. Remember that domain is simply a list of all the possible x values. And I'm going to teach you a new way I want you to give me that list of values. For example, let's start off with a really easy one right here, and that is that the function f of x equals 3x squared plus 2x. Pretty easy looking function. Remember our two big issues with domain, two domain issues that we talked about in class. The first one is square roots. When you're working with domain, no negatives, right? Little negative sign there. No negatives in the square root. Cannot have any of those. So you got to find a way to make sure that your domain only includes values that do not create any negatives inside square roots. Also, the second thing we have to worry about, is no zeros in denominator. So if you have a rational function, meaning there's a numerator and denominator, make sure that denominator cannot have any zeros, and values that make it zero need to be avoided. So let's look at this one, and the whole point of why I'm starting off with this one is there's no square roots, so you don't have to worry about any square roots, and there's no denominators, so you don't have to worry about any of that either. So this one has a domain that includes all real numbers. And in class we talked about this symbol representing real numbers, so we're saying the domain is all real numbers, but I want to teach you how to do something called interval notation. Interval notation is using an interval that says, okay, your answers or your values start here with the parenthesis, and they're going to continue until they stop here. So basically an interval is a start and a stop, moving left to right. Where do you want to start? Where do you want to stop? So for this particular problem, we're talking about all numbers. Every number works. There's no number that doesn't work. So what number would that start with? Negative 10, negative 30, negative 40, negative 100, negative a million? Actually, it would start all the way at negative infinity. Think about negative infinity as a concept of every number to the extreme left of 0. And then where do we stop? Well, we're talking about all numbers once again, so to go all the way towards positive infinity. So the interval notation for the domain that I would like you to give me is the domain is all values from negative infinity to positive infinity. And that would represent simply all numbers, if that makes sense. It should. So let's look at a second example here. Let's do f of x divided by 1 over x plus 2. Okay, so do we have any square roots to worry about? Nope, check. That's a good thing. Do we have any denominators? Yes, we do. So this number that's in the denominator right here, this x plus 2, that number cannot be 0. So I need to figure out what number makes it 0. Because I can figure out what number makes it 0, I can figure out what number I cannot be. So just for a split second, I'm going to set it equal to 0. And I'm going to pretend. What number makes x plus 2 0? It's really easy. Subtract 2 from both sides, and that number is negative 2. Now this is a bad number. This is a number I cannot be. Every other number works. So we would say the domain is all real numbers, comma, except x cannot equal negative 2. Now I want to teach you how to write this using an interval. So we would say domain. Now the interval starts with the smallest number you're allowed to be. Well, that's negative infinity once again, because I could be any number. In fact, I could also go all the way towards infinity. That would be where I end. However, there's the negative 2 that's somewhere in the middle that I cannot be. I need to skip over it. So we say negative infinity all the way to negative 2. Skip over negative 2, and I'm going to explain what all these symbols mean here in a second, and then continue on towards infinity. So I'm going to go from negative infinity to negative 2. This u means union, means I'm just going to basically skip over negative 2 and go towards infinity. So think about it. I can't be negative 2. So this part right here says everything less than negative 2 works. Anything below negative 2 towards negative infinity. This side over here says anything after negative 2, meaning negative 2 all the way towards infinity, works. So the domain in interval notation would be negative infinity to negative 2, take a break, real short break, and then continue from negative 2 on towards infinity. All right, let's take a look at another problem here. Let's look at one with a square root. So number 3 here. So f of x equals the square root of 3x minus 12. And we got to worry about that square root. So again, the number inside the square root cannot be negative, meaning it has to be positive or it could be 0. Positive meaning greater than 0 or equal to 0. Because remember, it just can't be negative. So 0 is actually neither positive or negative, so it's okay being 0. It just can't be negative. So let's solve this real quick. Add 12 to both sides. It's fairly easy. Divide both sides by 3. Still fairly easy. So x is any value greater than or equal to 4. So we would say the domain is all real numbers except x has to be greater than or equal to 4. But I would much rather give this answer in what we call interval notation. So think about the answer. It's every number greater than 4. So where does my interval start? Well, any number larger than 4. So it doesn't start until 4 because less than 4 doesn't work. And it's going to continue on all the way towards infinity. Now we need to somehow symbolize that it could equal 4, but it could equal 4. It's allowed to be 4. So I'm going to use a bracket. The bracket simply means that you're allowed to start at exactly 4. Parenthesis means you're starting at 4, but technically you're starting right after 4. Bracket means you're starting at 4. It means you're actually equaling 4. You can equal 4. If I couldn't be 4, let's just say I had to be strictly greater than 4, which means anything barely bigger than 4, then I'd use a parenthesis. So there's my interval notation. Start at 4, go towards infinity. Let's do a fourth example here. Let's look at one like this. A function is equal to the square root of x minus 3 divided by x minus 5. And this one's what I call a double whammy because I got a square root I got to worry about and I got a number in the denominator I got to worry about. So let's start with the denominator. Remember, the number in the denominator cannot equal 0. So I got to figure out what number is that I have to avoid. So set it equal to 0, add 5 to each side, and I get x equals 5. So the number I have to avoid is 5. I'm not allowed to be 5. I've got to avoid it. Up top, the number inside of the square root, the x minus 3, has to be greater than or equal to 0, just like above. Add 3 to each side. X has to be greater than or equal to 3. So that means that any number greater than 3 works, but I got to skip over 5. So how do I give this domain an interval notation? Start at 3. X has to be greater than 3. Start at 3 with a bracket because I'm allowed to equal it. And I'm going to continue until I get to 5. When I get to 5, I have to stop. Take a short break and pick up right again after 5. So I know this looks confusing, but it should make sense. I have to be any number from 3 to 5, and then any number from 5 towards infinity. The only number I cannot be is 5. So that's why I skipped over it right here. So I could be as big as 4.99999999999, or I could be just after 5 as 5.00001, but I cannot be 5. So that's why this interval notation should hopefully make a lot of sense. All right, next up is finding zeros. The easiest way in the world to find a zero is set it equal to 0. So we could start off with a simple function like 3x minus 15. So I got to simply say to myself, okay, let's see here. How could I figure out when this function's 0? Well, let me just set it equal to 0. And I'm going to solve. This is the first example for zeros. So add the 15. I get a 15 equals 3x. Divide both sides by 3. I get 5 equals x. So there's my 0. X equals 5. Okay. Now let's look at one that deals with some factoring. So I got f of x equals x squared minus 3x minus 54. Now, once again, I'm trying to find the 0, so I'm just going to turn that f of x into a 0. And this one is a little bit tougher to solve by hand, because if I try to start maneuvering things to both sides, I have an x and I have an x squared. It makes it pretty tough. So remember, with quadratics like this, you can use the quadratic formula to find your solutions, or you could factor. So I'm actually going to go ahead and factor. If you wanted to use the quadratic formula, you could do it. So how do I break apart an x squared? X times x. Those are the factors of x squared, because x times x makes x squared. factors of 54, where there's quite a few of them, but I need them to multiply to get negative 54 and add to get negative 3. So if you remember your multiplication table, that's 9 and 6, and I'm going to make that a negative 9 and a positive 6, because now the negative 9 times 6 makes negative 54, and then the 6x on the outside and the negative 9x on the inside add to make that negative 3x. So what are my zeros? Well, I got x minus 9 could be 0. I got x plus 6 could be 0. So add the 9, I get x equals 9. There's 1, 0. Subtract the 6, I get x equals negative 6. So I have 2 zeros for that particular problem. Not too bad. And let's look at one here that's going to have a fraction in it. Remember, we're not talking about domain anymore. That's another type of problem we were just looking at. We're talking about finding zeros. So let's say I got 10 minus 2x squared over 7 minus x. Okay. First off, if the bottom is ever 0, that's an issue. That's an error. We don't want to ever have that. So I don't even really care about what this bottom is. It's the top. I want to figure out what makes that top 0, because that's the number that would make the entire fraction 0. Denominators are not allowed to be 0 anyway. So let me just solve this. Let me subtract 10 from both sides. Negative 10 equals negative 2x squared. Divide by both sides by negative 2 here, and I get a positive 5 equals x squared. And then I got to take the square root. But remember, I put that square root there, so I need a plus and minus in front of it. Over here, the square and square root cancel. So I get two answers. I get a positive radical 5, and the second answer I get is a negative radical 5. Either one of these values could be a 0, so I have two solutions there. And let's just look at one more problem here that has a square root. Let's do the square root of, sorry, that's an ugly square root, x squared minus 16. So once again, I'm not finding domain. I'm worried about finding zeros. So I'm going to say, okay, let's let that function equal 0, and let's see what happens here. And the first thing I got to do is get rid of that square root. To get rid of a square root, I got to square both sides. So that gives me 0, because 0 squared is 0, equals x squared minus 16. Add the 16. I get 16 equals x squared. Take the square root, but once again, I added that square root, so I got to put a plus or minus there. And the square root of 16 is a perfect 4, so I get plus or minus 4. So I get two answers here as well, either positive 4 or negative 4. So hopefully finding zeros there makes sense, but you do have to know a little bit about square roots and fractions, and you also have to make sure that you totally understand factoring as well. All right, let's take a look at this quotient problem here. This difference quotient idea here. I want to go over that real quick. It was on the last page, I believe, of your homework. The difference quotient, don't let it confuse you. It's just this weird formula. It's f of x plus h minus f of x all divided by h. And all you have to do is kind of just follow it. Follow the rules of this thing. So let's start off with an easy one. The function is 4x minus 9. And most functions do have a difference quotient. And you find that difference quotient simply by using this formula up here. So the first part of the formula says plug in x plus h. So I have f of x plus h. And all that means is instead of using x, we're going to use x plus h. So I got 4 times not x, but x plus h minus 9. And I can go ahead and distribute that. 4x plus 4h minus 9. Now the formula says take that value that I just found, okay, 4x plus 4h minus 9, subtract the original function. I'm going to subtract the original function right here, subtract f of x. Now when you subtract, remember that means you got to run a minus sign through there, so I'm going to be minus 4x plus 9 because you're subtracting, so that minus sign gets run through. So please make sure you see that. I don't just put minus 4x minus 9. It's minus all of it. So it's minus 4x plus 9. And all divided by h. Just leave an h there. So if you notice on top, if you do it correctly, a lot of stuff usually cancels out. The 4x's cancel out, for example, negative, positive. The negative 9 and positive 9 cancel out. And all I'm left with is 4h divided by h. And this is great because I know that this is a fraction. There's an h on the top and the bottom, so they're going to cancel out. So I just get a final answer of 4. So that's a pretty easy one right there with a nice, real nice final answer. Let's take a look at a slightly more complicated one that's going to be involving a little bit more work. and I get it's 3x squared minus 4x. All right, so I'm going to start off with finding f of x plus h. That literally means just instead of x, use an x plus h. So I got 3 times x plus h squared minus 4 times x plus h. All right, I got to do some squaring first. Let's see, I'm going to do my dirty work over here. X plus h squared is x plus h times x plus h. That's going to be x squared on the outside, an xh on the outside, another xh on the inside. So that's 2xh. Again, that's outside xh, inside xh. That's 2xh's. Plus h times h, which is h squared. So I got 3 times x squared plus 2xh plus h squared minus 4 times x plus h. Now I can do my distribution. 3x squared plus 6xh plus 3h squared minus 4x minus 4h after distribution. Alright, so I'm good to go on that. Now all of a sudden I got to use the formula. The formula says f of x plus h, which I just found, 3x squared plus 6xh plus 3h squared minus 4x minus 4h. And now I have to, like the formula said, subtract the original function. Subtract the original function. So that's going to be minus 3x squared plus 4x. Don't forget, you got to run that minus through. And the formula says divide, wow, it's an ugly divide bar. Divide everything by h. So look what's going to cancel. Lots of stuff should cancel. 3x squared, negative 3x squared. Negative 4x, positive 4x. So I'm left with 6xh plus 3h squared minus 4h, all divided by h. And what I notice about every term on top that I'm left with is they all have an h. There's one h there, there's an h squared there, and there's an h there. So I'm going to factor out that h, and I get 6x, because I took the h away, plus 3h, there was a square there, but I took one away, minus 4. I'm going to divide all that by h still. And this is great because now there's an h on top, h on the bottom. They can cancel. And I get my final answer of 6x plus 3h minus 4. Final answer right there. Kind of a weird looking value, but that is the final answer for the difference quotient. So hopefully you can use all those strategies to help you finish up that worksheet that you were doing.